All right, this is exercise 4.3. It's another road grading exercise. Remember 4.2, we had a street with a curb and sidewalk. That would be like a city street, an urban environment. This roadway consists of an asphalt road, so you're going to have that same curved contour, but it drains 2% to the side, both directions, and then there's a shoulder at 4%, and then on this side here there's a V ditch with 3 to 1 side slopes of a V ditch. So this would be more of a rural type road situation in Washoe County, outside the city limits, city of Reno limits. Washoe County unincorporated you see a lot of roads like this where they don't have sidewalks. They just simply have a shoulder and then a swell to catch the water. So let's go ahead and do this one. What do we know? This is going to be at 16 scale. You can't see it, it's down here, but this is 16 scale as well. I'll have these. If you weren't in class or you need another copy, I will have these on Canvas as well. But this roadway here at 16 scale, I'll move this up here. You can see that this roadway there's 16, 18, 20, 22, 24. So it's 24. That's 16 to there. 17, 18, 19, 20, 21, 22, 23, 24. So this is 24 feet across. Each side, each half of the road is 12 feet wide. So it's sloping 5% downhill this direction, and then 2% on the roadway, 4% on the shoulders, and then 3 to 1. 3 to 1 is the same as 1 divided by 3, 33% slope. Same thing, right? So let's go ahead and do this. Just like the other problem, where do we start? We always start at the known elevation, and we got to find the nearest whole contour. So this is spot elevation 150.3. It's going uphill this direction, so we got to go uphill. So if 150.3 going uphill, we're going to find 151. 151 is going to be 0.7 feet away from 150.3. If you add 150.3, add 0.7 to that, you get 151. So we're going to find our horizontal equals vertical divided by slope. So we know our vertical, we just said it was 0.7 feet, 0.7, right? Because we got to add 0.7 to get to 151. So 0.7, we divide it by our slope. The slope of this road, which is 5%, 0.05 equals 0.7 divided by 0.05 equals 14. So if we measure 14, this equals 14 feet. If we measure this, right, 1 inch is 16, so we just got to subtract 2 of these. So there's 14 right there. And we'll just draw a line across. Nice little horizontal guideline, lightly. So this right here, this elevation is 151. And now we're going downhill at 2%. And we said this is a 24-foot wide road, but we're only going from here, we're going 12 feet, right? Half the road width. And we know the horizontal, we know it's 12 feet, we know the slope is 2%. We just don't know how far we drop vertically. And vertically equals horizontal times slope. So horizontal we said was 12 feet, times that by the slope of 2%, 0.02 equals 12 times 0.02, 0.24 feet. So it drops from here to here 0.24 feet. And if we drop 2.4 feet, we got to go up. And uphill is this direction. So if we go down 0.24, we got to go up 0.24. right, to find that existing, that 151 foot contour. So we don't know how far we got to go, but we do know we've got to go vertically 0.24 feet and at a slope of 5%. So what are we wondering? We're wondering horizontal, vertical divided by slope. Our vertical, we said, was 0.24, because if we went down 0.24, we got to go back up 0.24, and we're going to divide that by the slope. The slope is 5%, not 2%. Now we're going this way, so we got to use this slope of 5%. 0.05 equals, so 0.24 divided by 0.05 equals 4.8 feet. 4.8 feet. Going to double check. 0.24 divided by 0.05 equals 4.8 feet. So let's measure both sides. Where's my scale? 16, so we got to measure 4.8, which is almost 5. And on this side, 4.8, which is almost 5, right there. So now remember, we said it had to be an arch, couldn't be a V because it's asphalt road. If you did your reading in the book, you'll see that it tells you asphalt, difference between an asphalt and concrete, or asphalt and concrete road. And this is how you know it's different. Without even seeing this, you would know it's asphalt now because it has this crown. All right, so we went down, then we went up 0.24. Now there is no curb here, no curb. So all we've got to do is just from here, there's no curb, it's not going up or down, so we just continue. Now we've got to go 4%. So let's go straight across here, like this, just little guidelines. So now we're going to go from here down at 4%, because it's showing you going down 4%. So how far are we going? We've got a 6 foot shoulder, and we just scaled, they didn't tell you, you have to scale it off, 6 foot shoulder. So we're going, we don't know the vertical, which is horizontal times slope. So 6 feet is our horizontal, and we're going to multiply it by our slope, which is 4%. 0.04 equals 6 times 0.04 equals 0.24. So I guess that makes sense. If this is 12, so it's the same, 0.24, because this is 6 feet at 4%, this is 12 feet at 2%. So it's going to drop the same distance. 6 times 0.04 equals 0.24. So we just dropped 0.24. So now if we dropped 0.24 feet to here, what do we have to do to get back up to 151? If we dropped, then we got to go, if we went downhill 0.24, now we got to go uphill. Uphill is this direction. Uphill 0.24. So how far is that going to be at this slope? So we don't know our horizontal, vertical divided by slope. Said our vertical is the same, 0.24, because we went down 0.24, got to go up 0.24, and we know that divide that by our slope, which is 5%, 0.05, because we're looking at this going this direction, which is right here, 5%. So 0.24 divided by 0.05, 4.8. So this is 4.8 feet again, same as that. So just measure horizontally, 4.8, almost 5, so 2.4, almost 5, 2.4, almost 5 here. And just connect those. Right, like that. So far our water is going this way, leaving the road, and this way. And then here, same thing, it's going away from the road, which we want it to do because it's got to go in this ditch here. So now we've got 151 here. We've got to go right here. I'm just drawing a guideline right across. This is the center line of your ditch. It's going down to the bottom of the ditch or swell and then back uphill. So if this is going this direction downhill at a 3-to-1, which 3-to-1 is the same as a 33% slope, correct? So just 1 divided by 3 equals 0.33, 33% slope. So we're going, this is a 2, 4, 6, 8, 12 foot, so it's 6 and 6. So that's just happens to be the same as the same distance as the shoulder. So 6 feet at 33%. 1 divided by 3 equals 0.33%. So if we go 6 feet, what are we trying to find out? We're trying to find out what the vertical drop is. Vertical is horizontal times slope, so our horizontal is 6 feet. We measured 6 feet to the center line at 33% times 0.33 equals 6 times 0.33 equals 1.98 equals 1.98. So drops from here down to the center line, drops basically 2 feet. So this is a 2 foot deep swell or ditch or a ditch. So basically the way your road it looks in cross section, you've got this road, your road, and then you've got your little shoulder right here, your road, and then a ditch or a swell like that. And we're drawing this right here. We're drawing the ditch. So now we went down, we said 1.98. Now if we went down 1.98, what do we have to do? We have to go up 1.98. And if we go up 1.98, we have to do it at this slope, right? The slope of the road, 5%. So we're looking for horizontal, which is vertical. Vertical, which we said is 1.98 divided, we're like horizontal, vertical divided by 1.98 divided by the slope, which is 0.05 equals 1.98 divided by 0.05, excuse me, 39.6. 39.6 feet. Double check that just to make sure. 1.98 divided by 0.05. 39, so basically 40 feet. So we're going to go, this is 16, 32, 33, 34, 35, 36, 37, 38, 39.6, right there. Right like that. So I measured from here to here 39.6 feet. And then I've got to connect these. And I went down, so now I got to go, I went up, right? Because I'm going up this slope. Now I got to go this way. Back up, and it ends up at the same spot. So, like that. So now we've got a road in this ditch, and because it's 2 feet deep, it looks pretty extreme, but that's the way it comes out. So now you just follow these same principles. So this is going into this ditch, water's going off the curb into the ditch, or not curb, but off the side of the road, side of the shoulder into the ditch. Now this 3-to-1, what that tells you, what you know is, now your contours, your side slopes are 3-to-1. So if you drew if you just happen to draw a contour 3 feet away, let's do 3 feet and 3 feet. Connect those dots roughly like this. and I don't want, I'm just showing you. So this is 3 feet, that's 3 to 1. If you did 3 feet on this side, 3 feet and 3 feet, I'm just keeping that 3 to 1, connects you like this, that 3 to 1. So you can check if you did your 152, because right, we're going 151, now we got to go 152. It's going to end up tying in right there. So go ahead and do it, but I just wanted to show you that that 3 to 1, that's where that 3 to 1 comes in. After you do this, you just have to stay 3 feet apart, and those are parallel, and you're meeting this requirement. So go ahead and now figure out 151. We got to go uphill to 152. So now our vertical distance is 1 foot. So it's 1 foot instead of this 0.7. Now it's 1 foot divided by 0.05. You'll get whatever amount that is. You'll put your new contour here and continue with 2, 3, or 4 contours, however many you can fit on this exercise.